So it is like this. So nested functions. A function inside a function is called so if you are writing a function inside a function, then it is called as nested function. So what is the use of nested functions is, now these are the usages. Hiding function inside a function. Nested functions are used to develop special functions like so decorators and closers. Functions allows to split one function into number of functions. So it is like this. If you're writing a function inside a function, this is called as a outer function. Inside this, you write another function which is called as inner function. So print, this is called as inner function, or the same thing is called. So what will happen if I call the function 1? So what will happen if I call the function 1? So whenever you call the function, the control is switched from. So first which function is called main function, and main function calls which function? Function 1. That's all. But is it this function is executed? No. This function will not be executed. When this function is executed, see, function will not be executed automatically. Function has to be called. Now this function has to be called. You are calling this. Where we can call this function? Within function 2. So print inside which function it is? Outer function. This is which function here? Outer function. Inside outer function. So function 1 calls which function? Function 2. And function 2 print inside inner function. So here it is like this. So when you call the function 1, so my program execution starts from here, from main. So this is executable statement, and then call the function 1. And within function 1, there is 2 executable statements. That is function 2 and inside outer function. So it will call the function 2, and there is a message like inner function. Then the control will return to this, and then it will display the message inside outer function. So here inner function I can call only within inner function I can call only within outer function. Inner function I can call only within outer function, but not outside the outer function. Inner function I can call within outer function, but not outside the outer function. Now if you run this, now you can see inner function and inside outer function. So this kind of operations are useful, as I know, for developing some special functions like decorators and closers. You are trying to use this concept. Decorators and closers, you are trying to use this concept, right? This is in inner function and inside outer function. Inner function and inside inner function and inside outer function. So your inner function, inner function is called or invoked within outer function. Inner function is called or invoked within outer function, but cannot called outside outer function. So inner function is called or invoked within outer function, but cannot called outside outer function. So I cannot call here. Can I call the function 2 here? No. Because where is the function 2? Function 2 is there inside function 1. So where I can call this function 2 only within function 1, but not outside the function 1. Okay, if I'm calling here, the Python gives error, say name error. Name function 2 is not defined. Is it function 1? Is saying, do you mean function 1? Okay, so but function 2, only function 1 is visible. But function 2 is hidden within inside which one? Function 1. So I cannot call this function 2 outside the function 1. So I can use this function 2 only within function 1. So inner function can access local variables of outer function to perform what here operations. Inner function can access local variables of outer function to perform operations. Inner function can access what are local variables of outer function to perform certain operations. So it can access local variables of outer function to perform certain operations. So what is the meaning of this? For example, I write a function 1. So this is x equal to 100. This is local variable of function 1. Y equal to 200, and this is also local variable of function 1. And within this, I write another function, and this is called as which function here? Inner function. And inside this, I can access x and y. But is it any variable x and y inside the function 2? No. There's no variable called x and y within function 2. There's no variable x and y within function 2. But variables x and y are there inside what? Function 1. But there's no x and y within function 2. But there is x and y within what? Function 1. Okay. So I call the function 2. So this is main where I'm writing an executable statement called function 1. So whenever I call this function 1, now you can see 100 and what is output here? 100 and 200. What is output here? 100 and 200. So the output is given 100 and what? 200. Okay, so the output is given 100 and what is that? 200. Okay. So 100 is a value of x and 200 is a value of y. Okay, 100 is a value of x and 200 is a value of y. So outer function can access the value, inner function can access the value of which function? Outer function. Okay, so that using outer function data, it can perform certain operations. But it can access it, but it cannot modify it. So it can access it, but it cannot modify it. The inner function can access the data of outer function. Inner function can access the data of which function? Outer function, but cannot modify it. If I'm writing x equal to 500 and y equal to 600, so here 500 is assigned to x. So first priority is given to the local. Okay, first priority is given to the local. Now, is it any variable x in function 2? No. So what will happen? It will create variable. Create variable with name what? X. It will create variable with name what here? X whose value is what here? 500. The next is y equal to 600 means again create variable with name y. But is it this assign 500 to the x of function 1? No. So it is creating x and y variables inside what? Function 2. If I'm saying print x and y, it look for x and y within function 2. Is it x is there in function 2? Yes. 500. Y will, yes. So after calling the function 2, I print x and y values. So this statement is there in which function? Function 1. The statement is there in which function? Function 1. It look for x and y variables in function 1. What is the value of x here? 100. What is the value of y here? 200. The value of x is 100 and the value of y is a 200. X is 100 and y is a 200. Now you can see 500 and 600 and 100 and what? 200. 500 and 600 and 100 and what is that? 200. Okay. Yes. But you cannot assign values to the non-local variables. Now you can call this as for function 2, you can call this as which variables? Non-local variables. In function 2 point of view, this is called as which variable? Non-local variable. For function 2, x is a non-local. For function 2, y is a non-local. You can access this non-local variables inside function 2 directly. But you cannot assign values to this non-local inside function 2 directly. No. If you are trying to assign it, it will try to create another variable with the same name, x and y. If you run this now, 500 and 600, these are x and y values of function 2. And if you say print x and y, this x and y are the function 1. But but my requirement is I want to assign values to the non-local variables within function, inner function. I want to assign values to the non-local variables within inner function. So for that, you are trying to use a keyword called non-local. For that, you are trying to use a keyword. So what is that keyword you are using is non-local. You are trying to use one keyword here. And what is that keyword you are using is non-local keyword. You are trying to use one keyword here. The keyword what you are using is non-local keyword. So you are trying to use one keyword here. What is the name of that keyword is non-local. This keyword is used. Okay, this keyword is used to access or to assign values to assign value to non-local variables within inner function. Inner function or what is that? Nested function. This keyword is used to assign values. This keyword is used to assign values to non-local variables within inner function or nested function. This keyword is used to assign values to non-local variables within inner function or what? Nested function. This keyword is used to assign values to non-local variables within inner function or what? Nested function. So you are using a keyword called non-local. So there's a keyword non-local followed by variables list. So you just give the variable name. So if you want to assign values to this non-local variables, we'll say non-local x comma y. Now in this case, it is trying to refer to which variables now. You are saying that this x and y are not belongs to what? Function 2. You are saying that x and y belongs to which one? Function 1. So what will happen in this case? It will assign this 500. It will assign this 500 to the x of function 1. It will assign this 600 to the y of what? Function 1. So the value of x will be 500. The value of x will be 500 and the value of y will be what? 600. The value of x is 500 and the value of y is what here? 600. Okay. So what is the value of x and y? 500 and 600, right? So if you run this now 500, 600 and 500, 600. But if I'm not writing this, what will happen? Will it assign this 500 to the x of function 1? No. It will create x variable in function 2. Because first priority is given to the local. Means it look for x variable in function 2. Is it there? No. Create it. But you don't want to create it. You want to refer to which one? Outer function variables. You want to refer to which variables? Outer function variables. And that is done by using the keyword called non-local. So always Python search for the variables by using one searching techniques. By using one searching technique, Python search for the variables by using one searching technique, and that searching technique is called as LEGB. So LEGB, Python search for variables, search or look up for variables, using method one method called LEGB. So here LEGB stands for first priority is given to local. Okay, and second priority is given to enclosed block. And third priority is given to global. And fourth priority is given to built-ins module. Fourth priority is given to built-ins module. Okay, built-ins module. So LEGB stands for local enclosed block, global, and one more is what here? Built-ins. For example, I declare one variable here x equal to 100. This is called which variable? Global variable. And inside the function 1, I said y equal to 200. This is which variable? Local variable. Inside the function 2, I said z equal to 300. This is which variable? Local variable. But for y is for function 2, it becomes what? Non-local. For function 2, what is the y here? Non-local. So here I'm trying to say print x. So first priority is given to the local. Is it any variable x in function 2? No. Next priority is given to the non-local. Is it any x variable in function 1? No. Next priority is given to the global. Is it x is there? Yes. Access it. Then print, I'm saying here y. It look for the y variable within function 2. Is it y variable is there in function 2? No. Next priority is given to function 1. Is it y variable is there in function 1? Yes. Access it. Then I'm trying to say print z. It look for z variable in function 2. Is it variable z is there inside function 2? Yes. What is the value of z here? 300. 300. No, I call the function 2 here. Okay, so first priority is given to the local, and next priority is given to the non-local, and next is global, and then built-ins also. Next priority is given to the built-ins module. So that is the default module. For example, built-ins module is having some variables. For example, there is a variable called a doc. Doc is a variable, I think. So I try to execute this. So what is a doc here? None. So doc is one variable. But is it any variable called doc inside the function 2? No. Is it any variable called doc inside the function 1? No. Is it any variable called doc in global? No. Then what is the default module imported? Built-ins. What is the default module imported? Built-ins. Is it that built-ins module is having doc variable? Yes. Access it. Suppose if you write any documentation, right? If you write any documentation that you can access it. If you write any documentation, and that documentation you can access it by using a doc. So this is function 2. Okay, this is function 2. Oh, this is global documentation, right? So z equal to this. So this is a program. Example of non-local. Okay. Example of LEGB. Actually, you provide documentation. Now, example of LEGB. So this is what your documentation. So this documentation is stored in one variable. What is that variable here? Doc. But where this variable doc is there, this variable doc is there inside one module. What is that module here? Built-ins module. Okay, so first priority is given to local. Next is enclosed block. Next is global. And next is what? Built-ins module. If it is not there in that built-ins module, then it gives error. Then it gives an error. Okay, then it gives what here? Error. If it is not there in that, then it gives a error. So that is the technique which is used by Python for searching variables. So first priority is given to the local. If it is not there in the local, next priority is given to the non-local. If it is not there in the non-local, then next priority is given to the global. If it is not there in the global, next priority is given to the built-ins. If it is not there in the built-ins, then it gives what? Error. Then it gives a error. Okay, then it gives a error if it is not available in built-ins module. If it is not available in which module? Built-ins module, then it gives a error. Let us see some examples, right? For example, there is a function called sum calculator. Calculator is a function which receive numbers and the operator. Okay, calculator is a function which receive numbers and operator. And calculator is having number of functions. Okay, for doing calculations, is having number of functions, like there's a function called which one? Add. So this add function returns n1 plus n2. There is a function called sub, return n1 minus, return n1 minus n2. So there is a function multiply and return n1 into n2. So there is a function called division. This return n1 divided by n2. So how many functions are there here? 4 functions. Like there is a function add, there is a sub, and there is multiply, and there is one more function called division. There's one more function called what? Division. So this is how you are doing it. So it means the calculator operations are divided into number of functions. And then now there is one variable result. Now result is a variable where based on the operator, suppose operator is, if the operator is a plus, I'm saying result equal to add function. Else if operator is, if the operator is minus, result equal to which function? Sub function. Else if operator is what here? Star. Result equal to multiply function. Else if operator is what here? Slash. Result equal to what? Division. So calculator is having how many functions? 4 functions. And you are invoking these functions based on operator. If you press plus operator, then call which function? Add function. If you enter minus operator, it calls which function? Sub function. If you enter a star operator, then it calls which function? Multiply. If you enter slash operator, then it calls which function? Division. And after that return what? Result. After doing operation, it returns a result, return result. After doing the operation, it returns what here? Result. Okay, now this is outer function and these are what? Inner functions. This is the outer function and these are the inner functions. So I'll try to input numbers. Integer of input. So enter first number. Enter first number, number 2 equal to input. Enter what is it? Second number. So enter first number and enter second number. Then here result. Result equal to, I'm saying even I have to send operator. So operator equal to input. I'm saying enter. Enter what is it? Operator. So calculator where I'm sending number 1, number 2, number 1, number 2 and what? Operator. I call the function calculator by sending number 1 which is received by n1, number 2 which is received by n2, and which also receive which one? Operator. If operator is a plus, it calls which function? Add function. And this add function return this n1 plus n2 into what? Result. And that result is written into this variable. So I just write here print format. So the result is I just display what here? Result. The result is I just display the result. Okay. So once you run this, now enter first number 10, second number is 5, the operator is plus. What is the result of this? 15. I try to input again. First number is 10, second number is 20, the operator is minus, the result is what? Minus 10. So, but based on the operator is calling which function? Add function. Minus operator then calls the sub function. Multiply operator then call multiply function. Division operator then calls which function? Division function. Now based on the operator, you are invoking a specific function. Okay. Based on the operator, you are invoking a specific function. If the operator is a plus, you are invoking the add function. If the operator is a minus, you are invoking the sub function. If the operator is a star, you are invoking the multiply function. If the operator is a slash, you are invoking what? Division function. Now that invoking is based on which one? Operator. That is based on the operator, you are calling a specific function here. Okay. Yes. Yes. So why we split this calculator into number of functions, so that if any changes, for example, if any changes in one function, suppose I want to do some changes in add, I can do the changes in add function only without doing any changes in sub function, multiply function, and what? Division. If any changes to be done in multiply, I can do changes only in multiply without doing any changes in add function, sub function, and what? Division function. So without doing changes in this, without doing any changes inside this function, I can do the changes in what? Other functions. So that is the advantage. That is the advantage of splitting one function into number of, splitting one function into what? Number of functions. Splitting one function into number of functions, right? But what? Not only that, not only that, yeah, you can write any numbers. Yeah, you can input any numbers. Okay, right now this is how you are writing a function. This is how you are writing a function inside a function. But by writing nested functions, you can develop some special functions like what? Decorators, and one more is what? Closers. So what is a decorator here? Decorator. Yeah, next what I'm telling you is decorator. Now this is also related with inner functions only. Decorators. So generally decorator is a special function. Decorator is a special function. Decorator is a special function which returns another function. A function which returns another function, right? Decorator is a special function which returns another function. So decorators are used to extend functionality of existing functions without modifying it. Decorators are used to transform the function, to transform function or to change the behavior of what function. You can change the behavior of function with the help of what? Decorators. So a function can be decorated. Means you can transform the function with the help of what? Decorators. So technical definition is so a function returning another function. Yes. So these are some predefined decorators here. So a function returning another function. A function returning another function usually applied. A function returning another function usually applied. A function returning another function a function returning another function usually applied as a function transformation using @ wrapper syntax. So these are some predefined decorators like class method, and one more is static method. Decorators. So decorating function these are function wrappers. For example, you write one function. This is one function. This is one function. And you want to transform this function to another function. You write one function and you want to transform this function to what? Another function. Then what you do is you write one decorator. What you're doing, you're writing one decorator. You're writing one decorator. And within this decorator, what you're doing is you're transforming this function. Means you write another function. Within this decorator, you write what? Another function. You write another function. So this function is transformed a function, right? You write another function where you transform this function. Inside this function, you are changing this function to what? New function. You are changing this function to what here? New function. So decorator. This is a decorator. Within the decorator is a function. Inside this function, you write another function. Why you are writing this function? To modify this function. Okay, to transform this function, you write another function inside the decorator. You're transforming this function, writing another function. This is old function. This is which function? Old function. And you're transforming old function to what? New function. You're transforming old function to new function by adding some new features. And then returning which function? New function. You are returning which function here? New function. Old function, you're transforming to the new function and returning it. So it means this function you are wrapping. This function is wrapped inside what here? Decorator. So decorators extends the functionality. So a decorator is a function which receive function and return function. It will receive the function. Which function it is receiving? Old function. And then returning which function? Transformed function. And that is what? New function. It is receiving old function. This decorator is receiving old function. Decoration. Decoration means, for example, there is one gift. Gift is there. There is a gift. One gift is there. You decorate it. How you decorate? You wrap this inside a wrapper. You wrap it. Now this is a decorator, right? within the decorator, which one is there? Gift is there. Okay, this is a gift which is wrapped inside what? A wrapper. Same thing. There is one function, and this function you want to transform. This function you want to transform to another function. Then what you are doing it? You are writing one function inside one decorator. So this function is what here? Transformed function. Anyways, this function you are changing to this function by decorating it. So this is decorating, right? So decorator is a outer function and is a function which is wrapped with another function. So simple meaning of decorator. So that is extending functionality of the existing function. So decorator function receive a function as an input. Decorator function receive the function as an input. Decorator function receives a function as what? Input. Decorator function receives a function as input, and return function as what here? Output. Decorator function receives a function as input and return function as what here? Output. So it means decorator is the outer function, and within that function transformation is done using another function. The syntax is very simple. Now this is a syntax of writing this decorator. So definition, you are saying function name, and it receive function input as what here? Argument. And within this, you write another function. This is which function? Transformed function. Means new function. And this function is with the same arguments of old function. Okay, same arguments of old function. Statement 1. Okay, statement 1, statement 2, and even you write or you try to invoke which function? Old function. You try to invoke which function here? Old function. So you are trying to invoke which function here? Old function. So it received the function as input. Okay, it received the function as input and return function as output. Which function it is returning? Which function it is returning? Transformed function. Which function it is returning? Transformed function. So it received the function as input and return the function as what here? Output. Which function is returned here? Transformed function is written. But return the function and receive the function and return the function. Suppose assume that just to see here. So there is a function 1. There is a function called print data. Run function. Print data is there. Or print message. So there is a function called print message. It's printing a message, Python programming or Python language. It is printing one message. What is the message it prints here? Python language. So the message what it prints is Python language. So that is print message. which print the message. What is the message it prints here? Python language. Okay. Okay. So print message, I call print message. So print message function is just print the message. Print message is a function, it print the message. What is the message it prints here? Python language. Now I want to decorate this. I want to decorate this print message. I want this Python language to display in one box. Then what I'm doing is I'm using one decorator here. Okay, what is a decorator is stars. So I want to print this message within the stars. So what is the name of my decorator? Stars. And this stars is a decorator, it receives one function. Which function it receives? The function which you are decorating. And after that, I'm trying to write another function called new print message. New print message. What it is printing is it is repeating star and calling the function, and again it is repeating the star ordinance, and after that returning new print message. After that it is written new print message. Means you are decorating one function. Which function you are decorating? You want to decorate which function? Print message. You want to decorate print message by using which one? Stars. This is a syntax of using decorators. You are using a decorator by using at the rate stars. Now print message is decorated with which one? Stars. It's nothing but you are sending which function? Print message function toward stars. Now f is nothing but which function? Print message. Okay, f is nothing but you are calling print message. But when you call print message, it calls which function? Stars. And it calls a stars function first by sending which function? Print message. And then returning which function here? New print message. Means actually your Python is not calling print message. Internally it is calling which message? New print message. New print message, what it is printing? It is printing stars. Then after that it's calling function, which is nothing but Python language. And after that it prints what here? Stars. So you are trying to wrap this functionality, you are wrapping inside another function. So f is referring to this print message in this case. So what will happen if I run this? You can see stars, then Python language, and then what again? Stars. So a print message I decorated. Now it can be applied. Okay, it can be applied. Decorator can be applied to either one function or more than one function. Okay, Python scripting language. So again, I'm decorating it by using what here? Stars. Again, I'm decorating it using what? Stars. Now you can see, I can call this function. What is that function I called? Info. You can see stars and then Python scripting language. And again, what here? Stars. But how internally it works this? Internally, what will happen is, you are calling info function. You are calling info function. Okay, you are calling info function, but info function is decorated with what here? Stars. So what Python will do, it will call the stars function by sending which function? Info function. So f is holding which function now? Info. Then what it is returning? New print message. New print message is written. Means it is invoking. Is it invoking info function or new print? New print. And new print is printing what first? Stars. Then F is referring to which function here? Info function, where it will print the message Python scripting language, and then again it print what here? Starts. So decorator will modify or change one function to another function. Using decorator, you can change the behavior of function. Using decorator, you can change the behavior of function. So the syntax of decorator usage is like this is a function returning another function usually applied as a function transformation using which syntax using which syntax at the rate wrapper syntax. Using which syntax at the rate wrapper syntax here. What is the syntax I use to decorate at the rate? At the rate, what is the name of this function? Starts. At the rate, what is the name of this function? Starts. At the rate, name of the function is a starts. So function transformation is changing the behavior of the, it's nothing but changing behavior of the function. It's nothing but changing the behavior of the function. That you can do it by using which one? Decorators. It is as simple as like this. You want to convert one function to another function. For example, I write a function one. Function one. I want to convert this function one to another function. I want to convert this function one to what? Another function. So I call the function one. So what is the message I'll get here is, okay, if I run this, what is the message I'll get here is function one. I want to transform this function to another function. To which function you want to transform? That function, you are writing it as a decorator. I'm decorating function one with what? Function two. So function two receive the function one and it will transform that function one to what? Another function called function three. It is transformed to which function? Function three. So function one is transformed. Function one is transformed to which one? Function three. And return which function here? Function three. Function one is transformed. Now, how can I write it at the rate function two? This decorator function two is transforming the function one into what? Function three. Function one is transforming the function two is transforming the function one into which one? Function three. You can see function one is transformed to what? Function three. If I don't write this decorator, function one is function one only. Function one is function one only, but I want to convert this function one. I want to transform this function one to what? Function three. Then I'm using which decorator? At the rate function two is converting this function one into what? Function three. Function three. Now you can see function one is transformed to what? Function three. In the same way, you can write it. You can write. So function is transformed. Instead of saying function one, function is transformed to function three. Suppose there is another function called function four. Print function four. Okay, function four I called. Function four print function four only. I want to transform this function four into function three. I want to transform this function four into what? Function three. Then I'm saying at the rate. At the rate, what is that? Function two. This decorator, function two decorator is transformed function four into what? Function three. Now you can see function is transformed to function three. Function is transformed to what here? Function three. So it means you are changing the behavior, right? You are changing the behavior of the function by using which one? Decorators. So function transformation is done with the help of what here? Decorators. Function transformation is done with the help of decorators. Function is transformed to function three and function is transformed to what? Function three. Function is transformed to function three. Again, you are saying function is transformed to the function three. So this will return the address of function 3. You are not invoking, you are returning. Invoking function is different, returning function is different. Invoking function is different and returning function is what? Different. So it is returning function. It's not invoking function, it is returning function. What you people are doing here? Huh? I said you, it will call the stars function by sending print message function. So f is referring to which function? Print message function. If you are calling f function means you are calling which function? Print a message function that will print Python language. Where are you? Concentrate. Concentrate here. Okay, right? So f is a function. I said no. Decorator is a function which receive the function as what? Argument. So function as an argument. So function to receive. If function 1 is decorated with function 2, function 2 receive the function 1 as an argument. Okay. And returning or invoking which function? Function 3. Here also function 4 is decorated with what? Function 2. Means function 2 receive which one? Function 4. When returning new function, the called which one? Function 3. But in function 3, are you adding the features of function 4? No. If you want to add that features, you call that function. If I'm saying f means it is nothing but which function? Function 4 in this case. M means which function in this case? Function 1. Means this function is wrapped inside what? Function 2. This function 4 is wrapped with what? Function 2. And returning new function. Returning what here? New function. Now, function is transformed to function 3, function 1. Function is transformed to function 3 and what? Function 4. So if you want to include the features of this function, you can call that because it received the function as an argument. This name can be anything. X, Y, Z, any argument name you can give. But why I've given f? F indicates here what? Function, right? For example, there is a function I'm writing called a division. Division is a function. Okay, division is a function and this function receives how many values here? 2 values, that is n1 value and it received 2 values, n1 and n2. Division is a function, it receives how many values? 2 values, n1 and n2. Then n3 equal to n1 divided by n2 and then return which value? N3 value. So this is which function here? Division function. So result equal to division, I send 10 comma 2. So what will happen? Division function is called. Division is called by receiving n1 as a 10 and n2 value as what here? 2. And 10 divided by 2 is 5.0 and that value is written into result. Okay, fine. So where I'm saying print. So what I'm printing here? Result. What I'm printing here? Result. Now once I run this, you can see the result is 5.0. The result is 5.0. Okay, fine. But what will happen if I'm saying division by sending value some 5 comma 0? So I call the function division. I call the function division. Division is called by sending 5. And what is that next one? 0. But is it possible to divide a number with 0? No. Then it rises what error? That is some 0 division error. It rises one error. What is that error? It rises 0 division error. 0 division error. If I run this, you can see 0 division error. Division by what? 0. Okay, because a number cannot divide with what? 0. Now I want to transform this. Now I want to transform this function to another function where it can handle this 0 division also. Then what I'm doing is I'm writing one decorator. I'm writing one decorator called smart division. And the smart division wrap which one? Division function. The smart division wrap which function? Division function, and return new division. This is new division. New division. This function with the same arguments. Old division is having 2 arguments. New division is also having 2 arguments. But here you are checking, is it n2 equal to 0? Denominator. If n2 equal to 0, return 0. Otherwise what you do is you call old division function. You call old division function. Now f is nothing but old division function by sending n1 value and what? N2 value. And that will divide and return n3 value here. And that result you are returning it. You are calling it, and the result of that function you are returning it. Actually you are calling which function now? New division. Now I want to transform this division to which division? Smart division. So why? Because this division cannot able to handle 0 division, but smart division, it is able to handle which word? 0 division. So it means division I converted into which division? Smart division. Because within smart division, old function you are converting into what? New function. So that is a new division. Now if you run this, this is 5.0 and one more is what? 0. So it means actually you are calling which function now? New division by sending 5 and by sending what? 0. Is it value of n2 is 0? Yes. Return which value? 0. First you are calling division. Now actually you are calling which function? New division. 10 is received by n1 and 2 is received by what? N2. Is it n2 is 0? No. Then it will come to else and call which function? Division function by sending this n1 and n2 values. And that will divide and return this n3 value here. And that n3 value is written to main function. That n3 value is written to main function. Now this is 5.0 and one more value is what? 0. So it means division you are converted to what? Smart division. But the smart division is treated as what here? Decorator. So decorator, function transformation. Function transformation is done. Function transformation is done using what? Decorators. Function transformation is done using decorators. Okay, now this is one usage of using inner functions. Where inner functions are used for developing which one? Decorators. And where inner functions are used is one more usage of inner function is you can use this inner functions for developing one more, which is called as which one? closers. What is a closer and what is the need of closer? We'll see that tomorrow, right? So tomorrow we'll see how to work with the closers, and even I'll tell you generators, right? So we'll stop here today and tomorrow we'll continue this, right? Thank you.